Welcome to your Kotlin interview prep crash course. Whether you have an interview coming up or just want to sharpen your Kotlin skills, this video is your go-to guide. We'll cover 60 essential Kotlin questions, focusing on everything from basics to advanced coroutines. Each section is designed to refresh your brain and boost your confidence, with practical examples and clear explanations. Think of this as your Kotlin brain gym, short, focused, and energizing. Let's dive in and get you ready to impress any interviewer with your Kotlin knowledge. Start with the basics. What is Kotlin? Kotlin is a modern, statically typed programming language developed by JetBrains. It runs on the JVM, can be compiled to JavaScript or native code, and is known for its concise syntax, null safety, and seamless Java interoperability. In short, Kotlin is like Java, but with fewer keystrokes and more developer happiness. Understanding this foundation sets the stage for everything else you'll encounter in Kotlin interviews. Why choose Kotlin over Java? Kotlin offers several advantages: null safety, data classes, extension functions, higher-order functions, coroutines for asynchronous programming, smart casts, and less boilerplate code. These features make Kotlin more expressive and enjoyable to use, reducing common errors and making your code cleaner. If you're coming from a Java background, you'll appreciate how Kotlin streamlines everyday tasks. Null safety is one of Kotlin's standout features. By default, types are non-nullable, which means you can't assign null unless you explicitly allow it with a question mark, like string. Kotlin provides safe call operators, the Elvis operator, and non-null assertions to handle nulls safely. This reduces the risk of NullPointerExceptions, making your code more robust and reliable. In Kotlin, variables can be declared with val or var. Use val for read-only, immutable values. Once set, they can't change, like your birth date. Use var for mutable values that can be reassigned, like your mood. This distinction helps prevent accidental changes and makes your code's intent clearer. Data classes in Kotlin are designed to hold data. When you declare a data class, Kotlin automatically generates useful methods like equals, hashCode, toString, copy, and componentN. This saves you from writing repetitive code and makes your data models more powerful and concise. For example, a user data class can be compared, copied, and printed with minimal effort. Kotlin smart casts automatically cast variables after type checks, so you don't need to write redundant cast calls. If you check that a variable is a string, you can use it as a string right away. This makes your code safer and more readable, reducing the risk of ClassCastExceptions. The when expression in Kotlin is more powerful than Java's switch. It can be used as an expression or statement, supports type checks, range checks, and more. This flexibility allows you to write cleaner and more expressive conditional logic, handling multiple cases with ease. Kotlin supports both primary and secondary constructors. The primary constructor is declared in the class header and is the main initializer. Secondary constructors are declared with the constructor keyword inside the class and must delegate to the primary constructor. This structure gives you flexibility in object creation and initialization. The init block in Kotlin runs after the primary constructor, but before any secondary constructors. It's used for extra initialization logic, such as setting up properties or printing debug information. This ensures your objects are properly initialized before use. In Kotlin, == checks structural equality, calls equals, while == checks referential equality, same memory reference. This distinction helps you compare objects accurately, whether you care about their contents or their identity. Kotlin's functions and lambdas make your code expressive and flexible. Higher-order functions can take other functions as parameters or return them as results, enabling powerful abstractions. Lambdas are concise, anonymous functions you can pass around, making your code more modular and readable. Defining a lambda in Kotlin is simple. Use curly braces with parameters and a body. For example, a b greater than a plus b defines a sum function. You can assign lambdas to variables, pass them as arguments, and use them with higher-order functions for flexible, reusable code. When a lambda has only one parameter, Kotlin lets you use the implicit keyword instead of nomming the parameter. This makes your code even more concise, especially when working with collections and functional operations like map or filter. A function type in Kotlin represents the signature of a function, including its parameters and return type. For example, int. Int describes a function that takes two integers and returns an integer. This allows you to declare variables and parameters that expect specific kinds of functions. If the last parameter of a function is a function type, you can place the lambda outside the parentheses. This trailing lambda syntax makes your code cleaner and more readable, especially when working with DSLs or configuration blocks. The apply and with scope functions help you configure and operate on objects. Apply configures an object and returns it, while with performs operations and returns the lambda's result. Both make your code more fluent and expressive, especially when initializing objects. Let is great for null checks and returns the lambda result, using it as the object. Run is similar but uses this and is often used for initialization or combining expressions. Both functions help you write safer and more concise code. The also function is used for side effects, like logging or debugging, without affecting the original object. It returns the original object, making it easy to chain operations while observing intermediate results. Extension functions let you add new functions to existing classes without inheritance or design patterns. This makes your code more readable and reusable. For example, you can add a function to string or list to extend their capabilities directly. The inline keyword is a performance optimization. When used, the compiler replaces calls to the function with the actual function body at the call site. This is especially useful for higher-order functions, helping you avoid creating extra function objects and enabling non-local returns. In an inline function, a return inside the lambda can exit not just the lambda, but also the enclosing function. This is called a non-local return, and it's a powerful feature for controlling flow in higher-order functions. The non-inline modifier prevents specific lambda parameters in an inline function from being inlined, allowing you to store or pass them around. Cross-inline prevents non-local returns in an inline lambda, which is useful when the lambda is executed in another context, like a thread. Coroutines are Kotlin's solution for asynchronous programming. They're lightweight threads that let you write non-blocking code in a sequential style, avoiding callback hell. Use coroutines for network calls, database queries, and parallel processing. A suspend function can be paused and resumed later without blocking the thread. It can only be called from another suspend function or a coroutine builder, forming the building blocks of coroutines. This enables efficient asynchronous programming. Launch is used for fire and forget coroutines and returns a job, while async computes a result and returns a deferred t. Use launch when you don't need a result and async when you do. Both are essential for managing concurrent tasks in Kotlin. An abstract class in Kotlin cannot be instantiated directly. It can contain both abstract members to be implemented by subclasses and concrete members with implementation. Use abstract classes when you need a common base with shared logic. Interfaces in Kotlin define a contract of behavior. They can declare abstract functions and provide default implementations. Unlike abstract classes, interfaces cannot hold state. This flexibility allows you to design robust and reusable APIs. By default, Kotlin classes and functions are final. Use the open keyword to make them extendable or overridable. This gives you control over inheritance and allows for more flexible designs. A sealed class restricts inheritance, though all subclasses must be declared in the same file. This enables exhaustive when expressions, ensuring the compiler checks all cases. Sealed classes are great for representing restricted hierarchies, like results or states. Enum classes define a fixed set of constants. In Kotlin, enums can have properties and methods, making them more powerful than Java enums. Use them for representing a closed set of options, like colors or states. Generics let you create reusable classes and functions that work with different types safely. Kotlin supports variants without covariance for producers and in contravariance for consumers. This ensures type safety and flexibility in your code. Delegates let you implement the delegation pattern easily. You can delegate property or interface implementation to another object using the by keyword. This makes your code more modular and maintainable. Property delegation in Kotlin uses the by keyword. For example, delegates observable lets you react to property changes, while lazy initializes values only when needed. These tools help you manage state and initialization efficiently. You can delegate an entire interface implementation using by. This allows you to compose behaviors from multiple sources, making your classes more flexible and reducing code duplication. Use the lazy delegate when initialization is expensive or the value may not always be needed. It ensures thread-safe, on-demand initialization, making your code more efficient and responsive. A companion object is a singleton object tied to a class. It's used for factory methods, constants, and utilities, similar to static members in Java. This pattern centralizes shared logic and values. An object declaration creates a standalone singleton instance, while a companion object is declared inside a class and belongs to that class. Use object for global singletons and companion object for class-related singletons. Kotlin allows you to declare functions and properties outside any class. These top-level declarations are compiled to static methods, making them easy to use and organize, especially for utility functions. Kotlin's compiler can deduce types automatically, so you don't always need to declare them. This makes your code cleaner and reduces redundancy, while still maintaining type safety. The infix keyword allows you to call functions in a fluent, operator-like style. Functions must be members or extensions with a single parameter. This feature makes your code more readable and expressive. The structuring declarations let you unpack objects into variables. This works automatically for data classes and map entries, making it easy to extract multiple values at once and write more readable code. Kotlin is fully interoperable with Java. You can call Java methods, access fields, and use libraries directly from Kotlin. Likewise, Java can call Kotlin functions and properties. Use annotations like at JVM static and at JVM overloads to fine-tune interop. A coroutine scope defines the lifecycle of coroutines, tying them to a job and a dispatcher. When the scope is canceled, all coroutines launched within it are also canceled. This helps manage concurrency and resource cleanup. Coroutine builders like launch, async, and run blocking start coroutines. Launch is for fire and forget, async returns a result, and run blocking blocks the current thread. These builders are the entry points for concurrent programming in Kotlin. Structured concurrency ensures that coroutines run within a defined scope. If the scope is canceled, all coroutines inside are canceled too. This prevents orphan coroutines and makes your code safer and easier to manage. A job cancels all sibling coroutines on failure, while a supervisor job isolates exceptions, so one failure doesn't affect others. Use job for batch processing and supervisor job for UI rendering or independent tasks. Handle exceptions in coroutines using try-catch inside the coroutine or a coroutine exception handler for global handling. This ensures your app remains stable even when errors occur in concurrent code. With context suspends the current coroutine, switches context, and returns a result. Launch starts a new coroutine and doesn't return a result. Use with context for switching threads and getting results, and launch for fire and forget tasks. Kotlin provides dispatchers, I/O for blocking I/O tasks, dispatchers, main for UI updates and dispatchers, default for CPU-intensive work. Choosing the right dispatcher ensures your app remains responsive and efficient. Coroutine scope cancels all children if one fails, while supervisor scope allows other children to continue even if one fails. Use coroutine scope for strict error handling and supervisor scope for independent tasks. In Android, use viewModel scope in view models and lifecycle scope in activities or fragments. Always cancel coroutines in onDestroy if using a custom scope. Switch to dispatchers, I/O for background tasks, and keep UI updates on dispatchers, main. These practices help you write robust, efficient, and maintainable Android apps. Congratulations! You've just reviewed 60 of the most important Kotlin interview questions, covering everything from basics to advanced coroutines. With these concepts in your toolkit, you're ready to tackle any Kotlin interview with confidence. Keep practicing, explore more real-world examples, and stay curious. Kotlin's ecosystem is always evolving. Good luck on your interview journey. If you want to go deeper, check out resources on Kotlin coroutines, Android best practices, and advanced language features. The Kotlin community is vibrant and supportive, with plenty of tutorials, articles, and open-source projects to explore. Stay connected and keep learning. Thanks for joining this Kotlin interview prep journey. Remember, consistent practice and curiosity are your best tools for mastering Kotlin and acing your next interview. Wishing you all the best as you continue to grow as a developer.